So we have Module 2, Lesson 7. So today we're working on using the standard algorithm to multiply multi-digit numbers. So standard algorithm meaning this is what it looks like when you're multiplying. You have the digits lined up in place values, and then you have your times sign, and then one line, and then your partial products are going to go here, and then you add them at the end, and then your final answer is all the way down here, okay? So, first, number one, ABC. Number one says, draw an area model, then solve using the standard algorithm. Use arrows to match the partial products from the area model to the partial products in the algorithm. We're going to do this one a little bit differently. So on the ClassKick assignment, on the right side, I set up everything for you where you just need to, as you're multiplying them, you need to plug in which digits go where. Make sure you carry your numbers. And then on the right side of that same problem, you have the standard algorithm written again. And then your final answer will go in again right here. Okay, oops. So first, let's start with doing our standard algorithm. So we're multiplying 481 times each digit on the bottom, okay? So first we have 2 times 481, okay? So 2 times 1 is 2, so we would plug in 2 right here in the ones place. Next, we have 2 times 8, which is 16. So that would be 6 in the 10 place. And since we can only fit one digit per box, we have to carry the 1 into the 100 place. So now we have 2 times 4, which is 8. But we have to add that remainder of 1. So 8 plus 1, which is 9 in the 100 place. Okay. So now we have the next digit to multiply. So now we have 50, because the 5 is in the 10 place, that's 50 times 481. So, because we can do 5 times 481, and if this is 50 times 481, first, let's plug in that power of 10 that's in 50. So plug in 1 0 in the ones place here. Now we can just do 5 times each digit. So 5 times 1 is 5. So 5 right here in the 10 place. 5 times 8 is 40. So we would have 0 here in the 100 place. And then carry your 4 in the 100 place right there. So now we have 5 times 4, which is 20. But then we need to add that remainder of 4. Not this one, because we already used it in the last one. So we can cross it out or delete it. And then, so 20 plus 4, which is 24. So 4 in the 1,000 place, 2 in the 10,000 place. Okay, so now we're done with multiplying the 5. So now we need to multiply the 3. The 3 is in the 100 place. So we have 300 times 481. So 300 times 481 is also like 3 times 481, but we have 2 powers of 10. So first let's plug in 2 powers of 10. So 0 here and 0 here. So now we can do 3 times 1, which is 3. Then 3 times 8, which is 24. So we would have 4 here in the 1,000 place. And then carry the 2 right here. Make sure you don't use the 4 from before. So now we have 3 times 4, which is 12. So now add that remainder. So 12 plus 2, 14. So 4 in the 10,000 place. 1 in the 100,000 place. Okay, so now we don't have any more digits to multiply down here. So now we just add them all together. Okay, so starting at the right, 2 plus 0 plus 0. Whoa, 2. 6 plus 5, 11 plus 0, 11. So 1 here, carry the 1, but since this is a little squished, we're going to carry the 1 right down here, okay? And I already did that for you in your Classcake assignment. So now 9 plus 0 is 9. So 9 plus 3 is 12. 12 plus 1 is 13. So 3, carry the 1. Also, I put it down here. So now we have 4 plus 4, which is 8. 8 plus 1, 9. So 9 right here. So now 2 plus 4, 6 right here. 0 plus 1, 1 right there. So we have 169, 312. So that's we're going to plug in right here as well. So 169, 312. Okay? Okay, that is the first problem. Now the second problem, B. So I'm going to have to erase. On your paper, you're just going to scroll, on your assignment, you're just going to scroll down, and I just need to change one thing on the actual problem. I'm only changing this 10 place. So we have 481 times 302. So first we have 2 times 481. So just like the last time. So we have 2 multiplied by each digit. So 2 times 1 is 2. So 2 in that first blank box. Now 2 times 8, which is 16. So 6 here. Carry your 1 over into the 100 place. That's your remainder. So now 2 times 4, 8. 8 plus 1, 9. So 9 right there. So 962 is our first partial product. So now we have 0 times 481. So you can do this 2 ways. You can say, well, 0 times 481 is just 0, so I already know it's going to be 0. Or you can still plug it in and multiply each digit. So 0 for the 10 place, 0 times 1, 0. 0 times 8, 0. 0 times 4, 0. Okay? If you already know it's going to be 0, you don't have to write this in. You can just completely skip it and then just go on to the hundreds place, okay? So now we have 300 times 481. So now we know there's 2 powers of 10 and 300, so plug in your 2 powers of 10 first, here and here. And then you can do 3 times each digit. So 3 times 1 is 3. 3 times 8 is 24. So 4 here, carry the 2 into the 100 place. Make sure you don't use that 1 anymore. So now 3 times 4 is 12. 12 plus 2, 14. So 4 here in the 10,000 place, and then 1 over here. Okay, so now we don't have any more digits to multiply, so now we add it all together. So now 2 plus 0 plus 0, 2. Oh, wrong marker. So 2 in the ones place. 6 plus 0 plus 0, 6. 6 in the 10 place. 9 plus 0 plus 3 is 12. So 2 in the 100 place, carry the 1, which I did right here. So 4 plus 1 is 5. So 5 in the 1,000 place. 0 plus 4, 4 in the 10,000 place. And then 0 plus 1, 1 in the 100,000 place. So now we have our final answer. We have 145,262, which you need to plug in over here as well. So 145,262. Okay, so that's problem A and problem B. Next we have C. So C says, why are there 3 partial products in 1A and only 2 partial products in 1B? So just like I said before, you do not need to do this part. You can just skip it altogether. So the question is, how come in problem A there were 3 partial products, but in problem B, this one, there's only 2 partial products? So what is it about this place value, that makes this one only have 2 partial products? What does it have? Okay, so then just write a couple of sentences about why, and then you're all done. Awesome job. Make sure you do Zern time, and thank you for working so hard.